Hey man, hey, look. We're to talk about centroids again because some of you guys need to know about centroids again. Primero, let's talk about the basic shapes. So if you have a rectangle, then the centroid of that rectangle is just half of the base and half of the width. So if that's the base, width, height, whatever. The centroid is located at b divided by 2, and well, that's x bar. Maybe I should write that. X bar. X bar is b over 2. Y bar is h over 2. And that's just the distance from the reference axis if you choose the reference axis to be the normal x and y axes. So that's for a rectangle or a square. If you have a semicircle, then remember the centroid, well, x bar, that's weird. X bar is, well, it's just half of the base, if that's b. Then this is just b divided by 2. Y bar, though, that one is the different one, and that had a formula. And I think it was 4 times the radius. If we had a radius here, r, 4 times the radius divided by 3 pi. If you had a regular circle, it would just be half and half, just like a square. If you have a triangle, if you have a triangle like this, the centroid would be located, well, x bar would be the base, so that's the base, that's the height. It would be 1/3 times the base, or the base divided by 3, and then y bar would be maybe equals also 1/3 times the height. Now, if the those are the 3 basic shapes that we dealt with. If the triangle is in the opposite direction, like this, the centroid is over here. Instead of 1/3 this way, 1/3 of the base, it would be, if this is our reference axis, hopefully this makes sense, this would be 1/3. However, the distance to the reference axis, if you use just a common XY axis, then it would be just 2/3, right? Because 3/3 make up the whole side. So in this case, if the triangle is backwards like this, X bar would be 2/3 times the base, and Y bar, well, that doesn't change. That would still be 1/3 the height. Hopefully that's all fine and dandy. You're like, okay, that's good. What do I do now? What do I do now? Well, you pay attention and remember the formulas. For a complex shape, it's just the x bars, meaning the distance. Remember, this is the distance from the reference axis, so that you got to be very, very careful with that. The distance for the centroid of each individual shape from the reference axis, same with that, times the area of that simple shape, and then you add all of those together, and then divided by the sum of the areas right there. Okay, so let's do an example. Let's do one. Let's go. Let's have a go at it. So find the centroid. First I'm gonna split up my shapes. It's kind of already split up for me, so that's great. But I'll label them. I'll label my shapes. So this will be shape 1, shape 2 in there, shape 3. I'm going to say is that thing, and then shape 4 will be that triangle. And you also have to pay attention to the reference axes. I'm going to say the reference axes are going to be the normal x and y axes. So there we go. Those are my reference axes, and my xi and my yi, x bar I and y bar I. That's the centroid distance for each of these individual shapes to the reference axes. So, shape 1, and then let's go. Let's just do it. Let's do it. Shape 1. That would be a rectangle. That looks like it's gonna be, well, this whole side length. Now it's getting a little difficult. This whole side length cut in half, right? because that's what this says for a simple shape. It's just half of it. That's what we're deciding. So, for x bar, there we go. X bar is, well, that's 7.5 divided by 2. No. 17.5 divided by 2. And that's 8.75 inches. And that's okay if I just leave it like that, because that is the actual distance to my reference axis. So there we go with that. My y bar is just this middle distance right here. So let's see what that is. Well, looks like this whole thing is 15 from here to here. That whole thing is 15, so 15 divided by 2 is 7.5. So y bar is 7.5 inches. And I can do that. I can just divide that in half because this is already touching my reference axes. So that's good there. Shape 2. Oh, no. I need the area. And that's just 17.5 times 15, because that's base times height for the area. So there's the area. That's for shape 1. Yeah, moving on to shape 2. Shape 2 seems to be kind of nice. Looks like, well, we have this is going to be our y bar easily, and this is going to be our x bar, because remember, we're just halfway through the circle, so that circle's nice and easy for us. So shape 2. Oh, you know what? It wasn't given. We need to have the radius of this. I'm going to say that the radius, let's see, I'm going to just call that 2 inches, and then say it's given. So the area would be pi r squared. So pi times the radius of 2 inches squared. And it's a whole entire circle, so we leave it like that. Roughly 12.6 inches squared. So there we go. And this is a missing piece, so the area is negative. Don't forget that. It's a negative area. So there we go. Some people forgot that on the other quiz. And then we got this simple shape, number 3. So number 3, I'm going to do down here. Just remember, x bar and y bar is not simply, well, actually y bar is 6 inches, so that's easy. Y bar, that's going to be 6 inches. But x bar, it's not just the distance from here to here. It's the distance from here all the way to the y-axis, right? Because it's the distance to the reference axes. So what I have to do is find out half of this distance, and that seems to be 8 inches. Oh, no. The whole thing is 8 inches. So that means this distance is 4 inches. 4 plus 17.5. That's my x bar. So 21.5 is my x bar. My x bar. Frank, how'd you pass the bar? How'd you cheat on the bar? I studied for 2 weeks and it passed. Oh, he's like a genius. The area, well, that's just base times height. So we'll just do 8 times 15, is it, right? Yeah, 8 times 15. That's 120 inches squared. Do I have inches squared? Yes, I do. And it's a positive area because it's not missing. Okay, shape 4. We're on to shape 4, buddy! So, what we got? Well, whatever we get for x bar and y bar, we're going to have to add the x bar, we're going to have to add it to 17.5, and the y bar, that's this distance, we're going to have to add to 15. So, well, x bar is just 1/3 times the base, 8 inches, so that'd be 8 over 3. So that's approximately 2.7 inches. Y bar, oh, no. Remember, we have to add it. I just said it and I forgot it. 8 over 3, we still have to add, what was that? X bar? Okay. That was that distance. We need to add 17.5, right? Because that's this distance. So, plus 17.5, 20.16 inches repeating. Y bar, remember, we'll take 1/3 of the height, which is 1/3 of 5 inches. And that's 1.6 repeating, but then we're going to add it to the 15. And that's 16.5 16.6 repeating. 16.6 inches. So there we go. Very nice, very nice. And the area, well, that's just 1/2 times base times height. And that's just 60 inches squared. So that's what we have. Let's see, this is shape 4. Alright, in part 2, I'm going to use these formulas and put it all together to find my x bar and y bar.